All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? All right, good. Warm-up number 66 is on the screen. And once again, it's pretty much the same setup for all week. Hopefully, you should be able to do those by yourself. I'll give you some time for that. Ready and go. And today's going to go fairly quick because it's a minimum day. So everybody go like this. Bear with me, yeah? All right, let's do this. Yeah, the solution is where the graphs will intersect, yes? So, here are the answers to the warm-up. So this is number 1. Yes, so it's all there. Sorry for, because I'm recording this to load on the YouTube channel, and I forgot to press record after. No, I was recording, but I pressed pause, and I forgot to press again. Anyways, all right. Agenda for today. Copy this, please. Agenda, warm-up number 66, system of equations, and home place pages 197, 198, odds only. So last night you did evens, tonight is odds. Bam, that's right. Now, I'm sensing that last night the home play was a little bit challenging, yeah? Some of you might have had problems. See what I did there? You had problems for home play? See what I did there? Problem? Anyways. Be nice. All right. So, there is no asynchronous code. Last night's home play were pages 197, 198. It's found in Canvas under the Quadratic Equations module, evens. But I'm not going to pick that up till tomorrow together with the odds, because I want to go a couple of things just to make sure that you see the things that I'm trying to show you, okay? So tonight's home play are the odds. I'm going to skip through the objective and all that, systems. We said there's 3 ways of solving them. I want you to copy this table. Use half a page. Make a little prayer model, but label these, and like I said, use half a page so we can fit stuff in each of those little areas, okay? Copy that, please. So, this is going to help you with tonight's home play in case you got stuck yesterday with the home play. To figure out which method to use, so after we substitute, you need to end up with one side 0 and the rest with a quadratic whatever. And then you need to figure out a method into solving that equation. There's 5 different ways. Some of you tried factoring and it didn't work and you got stuck, and that's where you stopped. So let me show you the different views for factoring. The different views for factoring after you set it equal to 0 should look something like this. 0 equals x squared plus 5x plus 6. Can we factor that? Well, let's try. Bless you. What goes on top? The 6. What goes on the bottom? 5. So what 2 numbers multiply give me 6? Then when you add them, give us 5. 3 and 2, and that's where you do x plus 3, x plus 2. And then from there, each of those equal to 0, and the rest is history. Yes? Okay. However, that's not the only way of factoring. What if you end up with something like this? 0 equals x squared plus x. By looking at it, you can say, Mr. Hugh, I can't use Power Rangers because that only works for a trinomial. This is not a trinomial. So what else do we do in factoring when you end up with something like that? You check for what? GCF. Yes, right there. GCF. So what is GCF, Sky? I'm sorry? Yeah, for this one. X, and we're left with x plus 1. And then what do we do? Oh, like over here, watch. Don't continue with me so that you can see it. I mean, if you want to write, that's fine. Right. To continue this one, it would be x plus 3 equal to 0 and x plus 2 equal to 0, and you solve, yes? And here, the same thing. X equal to 0, x plus 1 equal to 0, and you solve. Okay? Next, what if I end up with something like this? 0 equals 3x squared minus 3. So whenever what you would do that one, it's still factorable, but in which way? Good conversations. Let's see. Help me out. Dana, what do I do there? Yeah, what is the GCF? 3, yes, and we're left with x squared minus 1 equal to 0. What do I do from there? Pass it to someone, Dana. That was good, man. That was good. Oh, man. So Miguel says that this in here, it looks like a difference of squares. How can we check? Can we take the square root of this one? Yes. Can we take the square root of 1? Yes. Is it a subtraction? Yes. So that means my factors are x minus 1, x plus 1, bring down the 3, equal to 0. And then the rest you set it equal to 0 and solve. All right. So that's factoring. Now look at this one. Look up. Don't copy this. Ready? 0 equals x squared plus 2x plus 3. By looking at it, you're like, wait a minute, I can factor, Mr. Q. All right, let's see. What goes on top? The last one, which is 3. 2 down here. What two numbers multiplied to give me 3? That when you add them, give us 2. Tell your neighbor. All right, let's see. Miguel, pass someone. Lenny, what do you think? What two numbers multiply give me 3 that when you add them give us 2? All right. Brianna, what do you think? No number. There is none. That's why this is not factorable. Not factorable. So what does that mean, Mr. Q? If I can't factor, then what do? I write it over here on this side. Write that down, please. And now I can use what? The quadratic formula. Yes? And everybody remembers that one, right? Yeah, tell your neighbor the quadratic formula. X equals minus b plus minus square root b squared minus 4ac over 2a. Yeah, there you go. So what does that mean, Mr. Q? That means that you need a value for a value for b, and a value for c. Substitute and simplify all the way till you get your 2x values, yes? All right, so underneath here, I want you to write ax squared plus bx plus c. So, what is c, everyone? 3. What is b? 2. And what is a? 1, because there's no number there, right? So it's a 1. Then you just substitute those in here and simplify. All right? Bless you. Next, what if we end up with something like this? 0 equals x squared minus 7. Some of you are thinking, couldn't we do the square root, Miss Q? Yes. But before that, at a first glance, some of you are thinking, can we do GCF? Well, let's see. Is there a GCF? No. Can we use Power Rangers? No. Can we use a quadratic formula? No, we're missing an x. So at this point, we need to leave x squared by itself, which means I need to add 7. Add 7 to each side. 7 equals x squared. And then, the last step, it's called square roots for a reason. We need to take the square root. So that leaves me with x equals plus minus square root of 7. Let me zoom into that. What do I have? Square root of 7. Do we know how to find the square root of 7? Yeah, share with your neighbor how to find the square root of 7. And no, I don't mean using your phone. Let's see. Lenny, pass someone. Who? Miguel? Between what perfect squares is 7 found? 1 and 9? Oh, 4 and 9. My bad. I thought I said that. Hands, if you agree with that, yes? Yeah, so that means this one is going to be approximately, square root of 4 is 2, so this is going to be 2 point something. So subtract that, that's 3. Subtract that, that's 5. So what's 3/5 in decimal form? 6. So those are our x's. And what do we do from there? For the system, we would substitute 2.6 into one equation, negative 2.6 into the other, and get our y, yes? All right. Graphing. If you end up with something like this, 0 equals x squared plus 5x plus 6, make sure that this, you change it to y. Why, Mr. Q? Because I said so. No, just kidding. Because you need a table. X, Y. Now, who noticed that on the home plate was scaled by 2s? Anybody notice that? Yeah, I don't like it because it throws us off with our graph. However, for the purpose of the home plate tonight, I want you to use the scales by 2 and start always with -4. So what would be my next value for the domain? -2, 0, 2, and 4, because it's scaled by 2. And then substitute the values, get the other value, plot your solutions, and kind of guesstimate where the solution will be for the system. And last but not least, completing the square. You're going to end up with sometimes something like this: 10 equals x squared plus 8x. So, tell your neighbor what I need to do here to complete the square. All right, good conversations. Bless you. Did I tell you guys that I used to stutter when I was in junior high? Yeah, I used to stutter, like when I went from elementary to junior high. At the beginning of the school year, they had me read in front of the in an assembly. And I'm like, really? Because I did really go with my academics. Let's go. But I stuttered a lot. So right away, of course, I was like, oh, I can't wait to be speaking in front of people. No. Anyways, also, did I tell you that I didn't speak for a lot for the first 3 years of my life? Did I tell you guys that? So when I was little, and mind you, I come from a very traditional family from down south in Mexico. I didn't speak for the first 3 years. I'm very observative, though. Very observative. Very observative. To the point that's why sometimes I notice some of you that are on your phone, right? Some of you that are doing other stuff. Some of you that your mind is elsewhere. I know where you're at because I'm very observative. So, the first 3 years of my life, I didn't speak a lot, but I've always, like, analyzed stuff. Well, there's a tradition in Mexico that if you don't speak when you're a kid, over there, instead of taking you to the doctor, they go grab one of the biggest bug that they can find, called a chicharra. Have you guys heard of those? You find them on the trees in the summer, and you just hear bzzz, big buzz, and you put it in the kid's mouth. I guess it works, right? Because now I can't stop talking. I want to bring some chicharras for someone that's like, tell your neighbor. Oh my goodness, chicharra time, let's go. Anyways, how do we complete the square? Miguel, pass someone. Andy. Very good. 8 over 2 squared to each side. Add 8 over 2 squared. Right? And then the rest is history. We end up with 16 plus 10 equals x squared plus 8x plus 16. This side is already a square. This one becomes 26, and the rest is history. Yada, yada, yada. Yes? Factor and so on. All right. So without further ado, let's go to the home plate. On your blank sheet of paper, copy this. We're going to do at least a couple together, see if we have time for as many as we can. We're going to start with number 14 from the home plate, okay? All right, here we go. Number 14, copy this one. Copy that on your paper, please. Yeah, I wonder how they got that idea of putting the bug in the kid's mouth so they can talk, right? That would be I wonder what I did actually when they did that. What do you think? That would have been funny. All right, here we go. To get started, second equation, what do? Raymond?
Minus y and add 7 to the x.
Add 7, yes, add 7. So we end up with y equals x plus 7. Okay, so now our second equation is equal to y, which means I can bring down the first equation. I'm going to write everything except which variable? The y, because now I'm going to substitute it with what? X plus 7. So I write equals to x squared 2x 7. But now instead of y, what goes there? X plus 7, yes. But it needs to be equal to what? 0. Solve. What do? Subtract x and 7. Yes, subtract x and 7 from each side. We end up with 0 equals x squared plus x, and the 7's cancel. Look at it. If you get stuck, look at your cheat sheet that you just did. Greatest damn, so let's go. What is our greatest common factor, everyone? X. We're left with x plus 1. All that equal to 0. Set each one equal to 0, so x equal to 0. X plus 1 equal to 0. Let me move this up a little bit. So this is already solved. This one minus 1. We end up with x equals -1. But since it's a system, we need 2 coordinates, don't we? This one is 0 here. This one is -1. That means, which equation do you want to use to substitute back in there? The bottom one? Yeah. I bring this down and I write it twice. Y equals x plus 7. Y, is that the bell?
Yeah.
For real? Alright, so then from there you substitute this in here, and then this one in here, and that's how you find your other solution. All right, guys, so once again, your home plate, do the odds. Hopefully that cheat sheet that you just made helps you out. Have a good one. I'll see you guys tomorrow. Bye.